Welcome to the House of Maths and my next vector question. Here it is, and it's quite a hard one. So we've got this shape here, which you can see is a triangle, and we're given some information about it. We've got the vector OA is A, so I'm going to put that one on. And we're told vector OB is B, so this is this vector across here. I'll just put it underneath like that. So that's vector B. We're told that M is a midpoint on AB, so this part here, M is midway along here. We're told that the ratio OP to PM is 3 to 2. So I'm going to put this bit here is 3/5, and this bit here is going to be 2/5. So that's the information we've been given, and the question we've got here, work out the ratio of ON to NB. So we've got to work out the ratio of this part to this part. So that's what faces us. So how are we going to do this? Well, as you look at the diagram, you can see that this is the vector that we're interested in. And we know that the full length of the vector is B. So we can look at the first part of it here, ON, and what we can say here is that vector ON is going to be some part or some fraction of vector B. So I'm just going to call that part or that fraction K. So that's the fraction of B that we're interested in. You could also say that NB, so this part here, is also a fraction of B. Well, if you think about the whole length is 1, if this length here is K, then this bit is going to be 1 minus K. So this is going to be like so. So we've broken that vector down into its two fractions. Of course, we don't know what those are yet. That's what we've got to try and find. So we've got this bit here. What we're going to have to do is try and find this bit in a different way as well. That's the way these questions tend to work. And the harder ones, you've got to find the same part of the triangle in two different ways, and then end up equating the coefficients. And it looks like you're going to have to do that with this one. So that vector there we could get by going OP and PN. So we've got to try and find, well, that's what I think we've got to do. We've got to try and find those bits. So to get OP, we know it's 3/5 of OM. So we need to find OM. But at the moment, we've not really got much. We've got this part, but we've not got that part. So we're going to have to find AB first. So I'm going to work over here. Vector AB, so that's this vector here, we can get by going down this way and across that way, because we know those two vectors. So that's that direction. It's going in the opposite direction to the arrow. So it's going to be minus A, and that's in the same direction of the arrow, so it's going to be B. So that's that vector AB. We're interested in this part here, AM, so that we can then get the vector OM. So AM is halfway down this vector. Like so. I can just multiply this out now. And in fact, I'm going to flip it the other way around to make it look a little bit neater. So you can get half B minus half A. So that's this vector here. So we can get OM now. We can go up here and down here. So it's A plus this. And then we can simplify that because we've got 2 bits of A in here. Okay, so OM here is up here and down here, which we've now got. Now we're interested in trying to get ON in a different way. So we want to go OP, PN. So this bit here, OP, we know it's 3/5 of this vector. So let's do that. Let's get OP. That's like that, and then we can just multiply out that brackets to simplify it. So we're going to get 3 times 1 is 3, 5 times 2 is 10a plus. Okay, so that's OP. Now we need PN. Well, we've not got anything there either, have we? So in order to get that, we're going to need to get AN. Okay, so we're going to need AN. And in order to get that, we're going to have to go down here and across here. So down here is minus A, and this bit here, ON, we're going to have to use this. Okay, we've got ON, we don't know what K is yet, but that doesn't matter, we'll still use that. So it's minus A, and it's going to be plus KB. Okay, so that's AN. And then PN is going to be some fraction of that. So this bit here is a fraction of that vector. And again, we don't know what fraction of it is. So we're going to have to come up with another letter to represent that. So I'm going to use N. Okay, so PN is going to be some fraction of that, and I'm going to call it N. Okay, so PN is this. So that's that bit there. So we've got OP and we've got PN. So we can now get ON in a different way. So ON, that vector ON is going to be this bit, it's going to be OP, which we've got here. So that's okay, that's that bit. And then we need PN, which we've just worked out here. So plus okay, so that's that vector ON. So we've got it in 2 ways now. We've got ON up here and down here, and we've got ON here, this bit here. So we should be able to work something out from that now. Now this is a little bit messy. I'm going to tidy this up first. So I'm going to multiply that out. So I'm just going to write this again. So 3/10 A plus 3/10 B. Now I'm going to multiply that out. Notice we've got a minus in here. So we're going to end up with minus AN and then plus KNB. Okay, now we've got 2 A's here. We've got 2 B's. So what I'm going to do is I'm going to factorise the A and the B. So I'm going to pull A out as a common factor. So I've got 3/10, and the other bit is like so. So I've factorised the A, and I'm going to do the same with the B. And I've got like so. And now I can compare that. I've got my ON, the vector ON here, and I've got the A component, and I've got the B component there. Now notice on this one here, ON vector, there is only a B component, so the A component must be 0. So over here, our A component, this A component here, the 3/10 minus n, that must equal 0, because there is no A component here to compare it with. It's just B in this direction, there is no A. So we can say that. So that means that n must equal 3/10 in order for that to be 0. Okay, now let's have a look at our B components. So B, so we've got 3/10 plus Kn, so 3/10 plus Kn, that must equal this B component here, which is just K. That must equal K. And we've obviously got two unknowns in here, but we've just worked out what n is. So we can substitute n in here, and then we'd be just left with one unknown. So let's do that. So we got 3/10 plus K like so. So I'm going to subtract this from both sides. So I'm going to get 3/10 here equals 7/10 K. And then I'm going to have, if I divide, I'm going to divide both sides by 7/10. So here I'm going to get K equals 3/10. Now I'm going to make it a multiplication by flipping it upside down, like so. So I'm going to get 30/70. So K equals 30/70, or we could simplify that and say K equals 3/7. Okay, so if we, what's that mean? K is 3/7. So K is this fraction here of this part of the vector. So this bit here is 3/7. That's what we just found out here. K is 3/7, and K is this fraction of the vector. So the other part has got to be 4/7, because the whole of the vector is 1. So 3/7 is this bit, 4/7 is this bit. And our task was to work out the ratio ON to NB, so this to this. So hopefully you can see that the ratio there is just 3/4. And we've solved it. Okay, so as I say, quite a hard one. And what you're looking to do with it, the main key with these tricky vector questions, probably round about, somewhere between a 7 and a 9 on a GCSE paper, you want to know something about this bit here. So you've got to try and find it in two different ways, and then compare the coefficients, or in this case we were able to do that and then work out the ratio from it. Sometimes you need to find the coefficient, sometimes it's the ratio. In this one it was a ratio, but the trick is, that's what we're interested in. Try and find it in two different ways, and then you can solve it. Hope you enjoyed that. Thanks for watching. If you did enjoy it, hit the like button and think about subscribing. Thanks very much.